Hello there, I'm Lukram and welcome to this video of tips and tricks. This is episode 2 and today we're talking about cars and what the new blocks can offer to the car makers in Trailmakers. Alright, so as you can see I have 3 beautiful cars here. To the left we have a Mad Max inspired vehicle that I built quite a while ago. To the right we have the Jurassic Ford Explorer from Jurassic Park, and in the center is my newest one. This is a supercar made for Ghost Raptor's tournament of supercars. Alright, so as you can probably guess, the supercar is the one with the new parts and the other 2 have older methods. So we're gonna go through them and we're gonna see the differences in what each thing does. Alright, so first on the list is the oldest one, the Fury Road inspired vehicle. The biggest concern you might have when building a car is for it to not flip over when you turn, and this is something we have a bunch of ways to fix for quite a while. This is one of them, using helicopter servos and combination of distance sensors to see if the car is tilting. That's the thing working. Every time the distance sensors trigger, it signals the single helicopter servo to turn on, and it returns it to that state, but as you can see it's quite janky. And the problem is the ramp up time with the helicopter engines. So this is the first method, and it's okay, but it could be better. So the next method to stop the car from tumbling over is used in this Ford Explorer, but it is not good for a lot of circumstances because the method is lowering the center of mass, and we can show that here. This part goes up, so the center of mass is gonna be in reality about here, somewhere over there, but it is quite low, so that means that it doesn't have a chance to get outside of the wheelbase, and that's what causes the cars to topple over, the center of mass getting over the wheelbase. The biggest problem it has is that it's quite heavy. It's 1,000 kilograms. This means that you're gonna need a lot of engines to move it. You can also forget about surviving jumps because all that weight is gonna make the impact a lot worse. This is the second method, but we have something better, being the new gyros. Finally, to the newest addition to the collection. As you can see, this car won't topple over no matter how much I try to spin it, and this is because it's using basically the same method as the first one, using distance sensors to check if your car is turning over, but instead we're outputting a gyro, and this gyro is set to strength 10, so it has rotational dampening, so it makes it harder to rotate in this axis, which is what we want because we don't want to topple over. And the good thing is that the gyros are instant, they don't have a ramp up time. So this makes the distance sensors quite effective because they are no longer restricted by the ramp up time of the helicopter engines, and you can set the exact output level you need for the gyro. This case is 0.2, that is 20% of the strength 10 gyros, and obviously the other one is negative, it goes to the same gyro, and that's quite easy to make. So that is the balancing system. The next thing we're gonna be checking out is hidden over here. This is another gyro. This gyro is also set to strength 10, so it is going to be rotationally dampening our spinning out, so we are less likely to spin out and we can drive straight. But it also controls something else, because I have a logic setup that activates once I press shift, and that enables the fast mode. And at fast mode, the steering hinges on the wheels are simply not enough, so I activate the gyro to drift, and it is quite fun, I must say. And yeah, it allows us to turn very quickly at high speeds before we needed to do some extra shenanigans. And this is extremely simple to make it very easy. All it is the gyro here at strength 10 is getting output from not that one, this one, these two AND gates. Yeah, this is 0.8 and negative 0.8. They go to the gyro, and yeah, you can tune that up however you'd like. The last thing I'm going to show you that this car has is hidden here. I have a quantum rudder, and the quantum rudder, you would expect it to be using it in a spaceship, not a car. But what the quantum rudder does is that it redirects the momentum of your vehicle to the direction the quantum rudder is pointing. So theoretically, we get to keep more of our forwards momentum after turning. And we can show that doing a little experiment. So I'm gonna speed up and drift, and we're gonna see the drift marks. And then I'm gonna do the same and compare it to the drift marks with a low quantum rudder. Alright, here we are at about the max speed of this car, so we're gonna drift. There we go. And we can check out the drift mark. So it took up quite a bit of space, but we can easily count how many squares it takes us to drift and change direction. Now we're going to change the settings to reduce the strength to the minimum. Alright, there we go, almost the same max speed. You can see it basically did no difference at all. So now we're gonna drift and check out the drift mark. And immediately we can see that it's quite different. It is a lot longer. So another thing you might have noticed is that this car doesn't have a name yet. That's because I haven't thought of one really. I would like to have your input. So yeah, feel free to comment down below if you got any name ideas for this car I made. Alright, that will be it for this video. I hope you enjoyed and that these tips and tricks helps you build a car in the future. And yeah, with that, bye!